Last episode, we built a dataset dict, train and test splits, both tokenized, both carrying input IDs and attention mask. Here's the payoff. That object plugs straight into the trainer. You pass train dataset your train split and eval dataset your test split, and the trainer already knows how to batch them, pad them, feed them to the model, and score them. No glue code. The thing you spend APO for preparing is the thing the trainer eats. So today we actually fine tune. We take a pre-trained model, point it at our data, and watch the loss come down in about 20 lines. First, the honest truth about what fine tuning even is. You are not training a model from scratch. Somebody already spent millions of dollars teaching a model how language works. You're just nudging the last layer so it leans toward your task. Think of it as adopting a fluent speaker and teaching them your company's slang, a weekend, not a degree. Second, what a training loop actually is and why you won't write one. The old way: load a batch, run a forward pass, compute the loss, run back prop, step the optimizer, zero the gradients, repeat. For every batch, every epoch. Dozens of lines, 10 ways to get it subtly wrong. The trainer is that entire loop, boxed up and battle tested. Third, the three things the trainer needs from you: a model, a dataset, well, two splits, and a training arguments object, which is just a settings sheet, how many epochs, how big the batch is, where to save. Hand it those three, call.train, and the loop runs itself. Fourth, the one number you stare at: loss. Loss measures how wrong the model is on average. High loss, very wrong. Low loss, getting it right. When you fine tune, you want to see one thing: that number falling epoch after epoch. A falling loss curve is the heartbeat of training. Fifth, why you watch two losses, not one. Training loss is the model's score on data it's actively learning from. Of course, that goes down. Eval loss is the score on held out data it never trained on. That's the honest grade. If train loss drops but eval loss stalls or climbs, the model is memorizing, not learning. You watch both lines together. Sixth, the data collator. Your sentences are different lengths, but a batch has to be a neat rectangle. The collator pads each batch on the fly, only as much as that batch needs. So you're not wasting compute padding everything to the longest sentence in the whole dataset. It's the small smart helper that makes batching efficient. And seventh, an epoch. One full pass over your training data. 3 epochs means the model sees every example 3 times. More passes, more learning. Up to a point, then it starts memorizing. 3 is a sane default for a quick fine tune, and 3 is exactly what we'll watch the loss fall across. Here's the whole thing: one file, zo5 trainer.py, 4 pages. Load the model and data on page 1, define the metric on page 2, set the training arguments on page 3, build the trainer and call.train on page 4. Let's walk it. Page 1. We import automodel for sequence classification. That's the model with the classification head bolted on, ready to be fine-tuned. We import the tokenizer, the dataset, the collator, and the trainer pieces. Then we load a small pre-trained checkpoint with num labels as 2, because this is a 2-class task. And we load our tokenized dataset dict from last episode. Train split, test split, already carrying input IDs and attention mask. Page 2, we define how to score the model. We load the accuracy metric, then write a tiny compute metrics function. The trainer hands us the raw predictions. We take the argmax to turn logits into predicted labels, and we compare against the true labels. This function gets called automatically at the end of every epoch on the eval set. That's where our eval loss and accuracy come from. Page 3, the settings sheet, training arguments. We point output dir somewhere to save checkpoints. We set num train epochs, the authority, batch size 16 for both train and eval, and a learning rate of 2 and -5, the standard gentle nudge for fine tuning. Crucially, eval strategy, epoch. So it scores the held out set after every single pass. That's what gives us the dotted eval line. Page 4. We build a data collator with padding from the tokenizer, or smart per batch padder. Then we assemble the trainer, the model, the args train dataset and eval dataset straight from EP04's dataset dict, the collator, and our compute metrics. One object, everything wired. Then the only line that matters, trainer.train. The loop runs and the loss prints epoch by epoch. And there it is, loss 0.42, then 0.26, then 0.18. 3 epochs, the number falling each time, the eval line tracking it down instead of peeling away. That's a healthy fine tune. The model is genuinely learning your task, not memorizing it. But here's the catch. Loss going down is not the same as being right. Loss is a smooth proxy. It can't tell you which examples the model still fumbles. Next episode we point this exact trainer at a real sentiment classifier and rate its mistakes one cell at a time in a confusion matrix.